Alright, so here I've got a little experiment I've put together to test something that we're learning in our physics class, specifically the principles of electromagnetism. So I've got a DC power supply right here, getting about 18 volts from that. We're going through a resistor just since the thing doesn't provide enough, or doesn't provide that much current, and if you draw too much from it, the bridge rectifier starts to smoke, which obviously isn't a good thing. And then here I've actually got my test wire. You can see I've labeled the negative and positive ends of it, and also here I've got the lines of magnetic the magnetic field lines there, just so we know. I've got my permanent magnet over here. It's from a hard drive, one of the old hard drives with the larger magnets, and you can see I've labeled the north and south ends like so. And just to test that, you can take my word for it, but the direction that it ends up aligning itself, the north end of the magnet, come on, the north end of the magnet is now pointing north, which is actually correct because we refer to the poles of a magnet as north pointing, and that is then shortened to just the north pole of that magnet. So yes, north is attracted to north in this circumstance because of those reasons exactly. Now let me just take that off the string. Okay, and if I come back here, I'm just going to throw the switch. Alright, you can see my resistor is working just fine. Of course, it's actually a light bulb. About 2.5 ohms, I think I measured that to be. Now, you'll notice, you'll notice that as I bring the magnet closer to the wire, if I bring the north end up there, the wire actually moves up. And then if I bring the south end, the wire's moving down. Now I'm not actually touching the wire until I get too close. There we are. But hopefully you can see that.